Hello all, and once again welcome to the MATLAB tutorial. This is the second tutorial. In the previous one, we studied about the building blocks of MATLAB, that is scalars, vectors and matrices. In this tutorial, we will study about script files, function files, plots, loops and selection. We will also see how we can use all these concepts and create animations in MATLAB. So let's begin. Script files are simple .m files where we write and store a sequence of commands to be executed together. Instead of writing those commands in the command window, we save them in a script file so that we can have access to them whenever we need. We will look into a few script files already saved and some we will write now. In those script files, we will come across new functions and we will learn about them. Let's see the example script file sound.m. So this file will produce sound at f1 Hz for t seconds. It is always nice to write information about the file on top as it will help others to understand the code. And the green text which you see here are called comments. To write a comment, we begin with a percent symbol. Everything that comes after percent is information for the user. MATLAB will ignore all those lines. It's a good practice to write comments whenever and wherever it is needed. Now, Fs is the sampling frequency which we will use to sample our time t, which is the duration of the tone. Fc is the center frequency of the octave band. You will learn more about this octave band later in the course. F1 is the lower limit of the octave band and dt will store the discretized time. S will be the vector which will store this sine 2 pi f1 dt, and sound s, fs will produce the sound which is contained in vector s at sampling frequency fs. So let's hear the sound. Observe here that we have defined two more variables r and g, but they are commented. So it means that though we have written these statements, MATLAB will not evaluate r and g. As you can see here in workspace, MATLAB has evaluated only the variable s, but it has ignored the variables r and g which are commented. So if I want to comment s, the shortcut key is Ctrl R, and if I want to uncomment R, the shortcut key is Ctrl T. Suppose I want to evaluate all these S and R and G, and I want to play these sounds one after the other. So I will create a vector called tune, and the elements will be vector S, vector R and vector G, and we will give this input tune to sound. So we run the code and let's hear. Similarly, you can play with this tune command and you can generate various sounds. Now let's write a script file from scratch. So let's write a script file such that it will ask the user its name, and then it will flip the name and it will tell how many characters are present in that name. So we will begin with information about our code. This script will flip the name and count the characters it contains. We'll clear the workspace, we'll clear the command window, and now we will come across a new function called fprintf. So what this fprintf does is that it allows us to write information on the screen for the user to view. This is very important when the user interaction is involved. So let's see how we can use this command. Now we have to ask the user its name. So we will write fprintf enter your name. Now when the user will input his name, we should have a mean to store it. For that we will use the command input. So we will store that in the variable name. So name will be input, and if we put s after that, MATLAB will know that what the user has input is a string. Now let's first display this much, display name. So we will first save our file. Let's name it and save. Now we will run it. So MATLAB is asking our name and it is waiting for our input. So let's say we enter and MATLAB has displayed our name. Now if I want to keep this command but I don't want MATLAB to execute it, I will do a Control R and MATLAB will comment it. Now what happens if I omit this s, if I don't tell MATLAB that the input is a string? So let's see what happens if I now run the code again. This time MATLAB has given us an error. We wanted to input a string, but to input string we have to enclose the characters in single inverted comma. And since we have not done that, MATLAB does not know that what we have input is a string and it will give us an error. So if we have missed this s in input and still if we want to enter string, we can do it this way. And now we will enclose our name into inverted commas, and this time MATLAB will display our vector. So MATLAB has now displayed our vector. If we include this s, then we need not enclose our name each time in the inverted commas. Now we have to flip the name. So we do this by using a command called flip lr. lr means left right, flip left and right. Similarly, there is one more command, flip ud, which stands for flip up down. For no particular reason, let's say our variable is this, and flip lr, flip the vector name. Now let's see what the variable stores. We will again run our code. And this is our name this time, and when we press enter we expect that it will be flipped. Let's see, and it is. So one part of our code is over, that we have flipped the name. Now let's see how to count the characters in it. For that we will use command length. Length will give me the length of the vector. So let's say we have a vector v which contains 3 rows. So length v will give me length of the vector, that is 3. We will store it in variable L and length name. Now we will display length and see if we get the result. Okay, and we expect it to be 5, and yes, Gimli has 5 characters. Now we will see how to present our results in much more better manner. Again, here we will use the command fprintf. So fprintf you entered %s will tell MATLAB that here a string will come, \n will tell MATLAB to start a new line, and then we will tell the user how many characters it has. So it has %d. %d will tell MATLAB here an integer value will come. So it has %d characters. Again a \n to start a new line, closing inverted comma, so that MATLAB will show only the string which you have entered within the inverted commas, comma. Now we have to tell MATLAB that what will come in place of %s and what will come in place of %d. That we tell by sequentially mentioning the variable names. So the variable eman will come in place of %s and L will come in place of %d. Let's write a few comments so that we will understand it later. User enters name here. Name is stored in variable name. The vector name is flipped. Stores the length of vector name. Prints the result. So let's see. So this is how MATLAB will present the result. It will flip the name and it will tell me how many characters are present in it. Now let's come to function files. The difference between script file and function file is that a function file will have a definition line, and it will also have something called input output parameters. If you remember, in script files we have to define the variables in the code in order to use them. We could not pass any variables from outside. But in case of function files we can do so, and this gives them a lot of flexibility. Also, the variables that are created in the function are local. That is, they don't show up in the workspace. They exist within the function only. We will see what this passing of variables mean in a minute. Here are some of the advantages of using functions in your code. They increase the readability of the code, they reduce the size of the script, and they also help in debugging. So let's see a few examples of functions. So let's revisit our first script file in which we calculated the distance between 2 points. in that script file, if x naught is changing, we had to change x naught every time, save the script file and run it. Though it had advantages over writing those commands in the command window, still if there are too many x naught values, we have to each time we have to visit the script file, change x naught values and then find the result again and again. So let's write a function file and see how it makes our life simpler. So to start writing a function file, we can create it with new and a function. First we will rename our function. Let's call it dist bit, distance between 2 points. The input arguments which we will be passing into this function are x0, y0, x1 and y1. The output argument will be the distance between these 2 points and it will be stored in R, the same variable which we used in our script. So this first line just after the definition line, this is the definition line, and the first line will tell information about your function. So if you search in command window using help, what you will see is this line. So what our function does is it calculates distance between 2 points, and some details will go in the second line. Provide x and y coordinates of 2 points. The order has to be x0, y0, x1 and y1. And now let's compute R. So R is square root x0 minus x1 square plus y0 minus y1 square. First let us save this file. One thing should be carefully noted is that whatever function name you put here, you should save your file with the same function name. MATLAB will automatically do it for you, but in case you should remember that this function name should be same as your file name. So here we save our function. Now how to use it? So if you have to use the function, first requirement is that it should be present in your current working directory. So here it is present in this directory, so we can use it. So dist between, that's how we call the function. So x0, let's say, is 0, y0 is 0, x1 is 2 and y0 is also y1 is also 2. And let's say we store that distance in y. One more thing, observe here that the output parameter here is r, but we are storing our result in y. So we can do that. It is not absolutely necessary to use the same output parameter as your variable to store its output. So when we press enter, MATLAB will give me the distance between these 2 points. Notice one thing here, that though we are passing the variables values 0, 0, 2, 2, and they are getting stored in variables x0, y0, x1, y1, the variables won't show up in the workspace. Only y, which we have defined in the command window, has appeared in the workspace. So this is how we mean that the existence of the variables in function is limited to function. So I cannot use x0 outside. If I try to use, MATLAB will say variable x0 does not exist. Now let's see another function. If you remember our sound script file, there to find sounds at few different frequencies, we had to write 3 commands. So instead of that, we can just write one function and use it to generate as many sound vectors we need. Let's create a function. Let's call our function Sargam. The input arguments will be frequency at which the sound will be played and the time, the duration of the sound, and output parameter, the sound information will be contained in y. So again here goes the function information. This function will produce sound at f hertz for t seconds. Some details: user should provide frequency in hertz and time in seconds. Again, f is our sampling frequency, and we will define a vector capital T, which is our discretized time, begins from 0, sampled at this rate, up to time t, which is input from user, and y will be sine 2 pi f and capital T. So let's save this Sargam, and now let's revisit our script file. Now instead of defining all these things here, we just have to mention time and the frequency. Let's say our frequency is 707 and my S or SA will be, so I will call the function Sargam by its name. I will tell that the frequency is FC. As you can see, MATLAB is prompting help. It will tell us what it expects as the next input. Now that we have input the frequency, MATLAB will ask me what is the time. So time is t, 1 second, parenthesis close, and we are done. Let's see how it works. Now if we want to say ray, which is at frequency for the time t. Similarly, we can, let's say we produce a few more vectors. Here we have defined four sounds. So instead of writing sine 2 pi ft, sine 2 pi ft for each of them, we are just passing the frequency and time for each one of it, and the function sargam will evaluate the vector, and the result will be stored in the corresponding variables. So let's just create a tune using this, and let's hear it. We will suppress the output and tune. So let's hear it. You can create many more tunes using this. It's a very good command sound. Play around with it. There are two more function files that we will write, but for that we will need the prerequisite of if else statements and plot functions. So we will first learn about them, and after that we will again write two more function files in much more details with much more complexity. We will now see selection. First, let's learn what relational and logical operators are. So, relational operators, as the name suggests, compares two statements and returns 1 if true and 0 if false. So, this table here lists relational operators. Let's try a few of them. So, let's say x is 2 and y is 8. So first we will see the equal to operator. So if I write x equal to y, what I am asking MATLAB is to compare if x and y are equal, that is if x and y have same value. So if it is true, z1 should get value 1. If it is false, we will get 0. Since they are not equal, z1 is 0. Now let's create a vector of zeros and ones using relational operators. So we will store that in Z2, and first let's ask MATLAB if x is less than y. Next, if we will ask MATLAB if x is greater than y, then we may ask is x plus 5 greater than or equal to y minus 2, and if let's say is x square less than or equal to, or let's say if x cube is less than or equal to y square. So we will accordingly get a vector of zeros and ones. So here we see the entries of Z2 are 1 0 1 1. So is x less than y? Yes. So it's a true. Is x greater than y? No. It's a false. So we get second entry as 0. Now x plus 5 is 7 and y minus 2 is 6. So is 7 greater than or equal to 6? Yes. So it's a true statement and we get 1. Similarly, is x cube less than or equal to y square? So is 8 less than or equal to 64? Definitely. Therefore the statement is true and again we get 1. So that's how the relational operators work. Now we will see how we can use them with array also. So suppose I have a vector x1 which is, let's say, 1 2 minus pi, and let's say 7 9.8 11 13 12. Yeah, and we have another vector 1 to 8, and we will use a semicolon to suppress the output. Now if we want to compare the elements, if we want to compare two arrays, so if I say, let's store the result in v1. So if I say v1 equal to x1 equal to x2, so MATLAB will compare each element of vector x1 with each element of vector x2. It will see if they are same. If they are equal, MATLAB will return 1, else it will return 0. So as we can see, only the first two elements will match, rest since it is false we are getting a 0. Now let's create a vector v2 which will store the output of this relation. We will compare elements of x1, are they less than or equal to elements of x2. So this is what we get. So this is our x1 and x2. So as you can see here, only the first three elements in x1 are either less than or equal to elements in x2. From fourth element onwards, the statement is false and all the elements in v2 are 0. Now let's see logical operators. So logical operators determine the true or false state using Boolean algebra. In Boolean algebra, 1 is true and 0 is false. But in MATLAB, any non-zero value is true and 0 is false. Here also the logical operators are AND, OR and NOT. The symbols are tabulated in this table, and the truth tables for the operators are same as that of Boolean algebra. So let's see few examples again. So AND will return 1 if and only if both the statements are true. So true and true will be true for AND operator, and in MATLAB any non-zero number is true. Therefore let's see what x1 will be if I say 1.3 and 0. So it's true and false. So we expect x1 to be 0 and it is. Now similarly we can check for OR. So x2 will be, say, minus 3.28 or 0. So OR will be false if and only if both the operands are false. So in this case, since it is true or false, the solution will be true. So x2 will store value 1. What will be the output of this? MATLAB will first evaluate the inner brackets. So first it will evaluate x and y. Since x and y are both non-zero numbers, this is actually true and true, which will result in true, and this bracket is true and false, which will result in false. So true or false will again result in true, and then we are using a not operator, so not true will be false. So x3 should be having value 0. So this is how we use the relational operators and the logical operators. Now let's see the actual selection part. So we have previously seen that MATLAB executes statements sequentially one after other. Not always we will want MATLAB to run the entire code as it is. We may want to run different statements under different conditions. So we will accomplish this using the selection statements. MATLAB provides two options for selection. First is if else statement. other is the switch statement. So how does MATLAB decide which case to run? It uses the relational and logical operators to arrive at the decision. If we have to represent this selection in form of a block diagram, we can illustrate it as shown here. So this is the start of our program. Then we will go to this checkpoint where it will check a certain condition using relational operators or logical operators. For example, we check that whether x is less than y, something like that. So if x is less than y, we would want this block to run. So if it is true, MATLAB will execute these statements and again we will join the main program and end. And if it is false, MATLAB will execute these statements and again we will join the main program and we will end. Many a times there will not be just two conditions, like if it is true, follow this or follow that. We may have several options, like if it is true, follow one path, else there may again be two options. So in that case we can use these nested if else statements or these if else statements. So again we will see how it is represented. So here again we start our program, we reach a checkpoint. Now let's say here we check with the condition if x is equal to y, that is if x and y have both same values. If it is true, MATLAB will execute these commands and again we will follow the main program and terminate it. Suppose x is not equal to y, so in that case we may have again two options, whether x is greater than y or x is less than y. So again if x is less than y, we may follow this path. If x is greater than y, we will follow this path. So it will execute these commands and again here we may have some nested paths. So this is the main if else statement. Then here we again have an if else statement within this if else statement. So here again let's say MATLAB will check whether x is positive or negative. So if x is positive, we will execute these commands. If x is negative, we will execute these commands and then we will return to the main program. So in this way you can use the nested if else statements and you can explore as many conditions or choices available. So let's see example of a simple if else statement, then we will see example of a nested if else statement. Let's write it down from beginning. First we will tell what this script does. So this script will tell if the entered number is real or complex. So first we will clear the command window. So first we will clear the workspace, then we'll clear the command window. Now we will use the function input which we had seen in the script files. So n will store the number and we can write input, and instead of using printf and input combination, we can directly write the prompt in this inverted commas. So we will ask user to enter number and we will wait for user input. Now since we are expecting integers or floats, that is we are not expecting the user to input a string, so we will not use that comma s which we had previously used in script. So if we use it here, then MATLAB will assume that we have entered a string, but here we don't want string, we want numbers. So we won't use it, and let's leave it at that. Now im variable will store the imaginary part of the number which the user will input. So how do we extract the imaginary part of a number? We can use the command imag. So imag will extract the imaginary part from the number. Now we can use if else statement. So we start with if we compare im to 0. So if imaginary part is 0, then print and new line. Else, now here we need not mention the condition that im is not equal to 0, because if im is equal to 0, the other condition is im not equal to 0. So if this is false, this has to be true. And don't forget the end to tell MATLAB that here the if else statement ends. So let's save our program. And let's run it. This time we will run it using the name of the file x underscore if else. So we will go to the command window. So MATLAB has asked us the number. So how do we input a complex number? So we will enter the real part 2 and let's say plus. Now we have input the imaginary part. So in MATLAB, I and j represent imaginary numbers. So generally I prefer to write it as 1j star 3. So here the imaginary part is 3, and let's say what MATLAB gives us. So it tells us that n is a complex number. Now let us run the program with 3 plus 0. So it tells that n is a real number. So what happens if I just enter 3? So MATLAB will again say that n is real number because the imaginary part of 3 is 0. Now it may happen that sometimes we miss this double equal to and just write single equal to. Now let's see what happens. MATLAB will immediately tell you that this might be an invalid syntax, but let's ignore it for a moment and see what happens. So MATLAB does not run the file, and it will tell us that the equal to sign, if it is used single, it means that we are assigning the value to the right of it into the variable which is on the left. So in order to compare, we have to use two equal to signs. So this thing should be kept in mind. So let's write few comments. Now let's see an example which is nested if else. So this script will tell information regarding the real part of the complex number which is entered by the user. So here again we will ask user to enter a complex number. So here we will explicitly ask user to enter a complex number and x will store it. Now to extract the real part, we will use the command real parenthesis complex number, and we have seen how to extract the imaginary part. So A will store the real part and B will store the imaginary part. Now we will check if A is positive or negative. So first we check here if A is greater than 0. Now if A is greater than 0, then again we will check two more conditions, that is A even or is A an odd number. So if mod of A with 2 is 0, that is if A is divisible by 2, we know that A is an even number. So we will ask MATLAB to print that the real part of x is a positive even number. So, and if mod of a comma 2 is not equal to 0, which means that a is an odd number, and MATLAB will print that it is a positive odd number. So what happens if this condition fails? So if a is not greater than 0, it may mean that either a is less than 0 or a is equal to 0. So we say if this fails, else if a is less than 0, then we again check whether a is odd or even. Accordingly we will print the statement. Finally, if a is neither greater than 0 and a is nor less than 0, there is only one possibility, a is equal to 0. So MATLAB will tell us that a is 0, the real part of x is 0. So let's run this program. So we will enter a complex number 2 minus 3j or 1j into 3. So our real part of this number is 2, which is positive and an even number. So let's see one more example. So now let's see a odd number, a negative odd, minus 3 plus 8. So now MATLAB should tell me that my real number is a negative odd, and it is. Now let's enter 0 plus, or we can just say 1j into 7. So MATLAB will tell the real part of x is 0. We can also use this switch statement instead of nested if-else statements. Note that we cannot use the relational operators like less than or greater than in switch statement. We can only check whether the condition is equal to several possible cases. So let's see the block diagram of switch case. So again we will start our program, and when we will reach checkpoint, unlike in case of if else where we could check whether x is less than y or x is greater than y, something like that, we cannot do that in switch case statement. We have to check whether the case is either case 1 or case 2 or case 3. If it is equal to either one of this, then MATLAB will execute this particular case, or if it is equal to case 2, it will execute this particular case, and so on. So if we had to replace the switch statement with if else, we would have to use only the equal to operators. We could not use other relational operators. So let's see an example of a switch statement. So here is an example. Let's run and see various cases, and then we will see how we have written it. So the question is, do you know the answer? If we say yes, we know the answer, MATLAB will prompt, so what is the question? Again let's run the program. So now if we say no, I don't know the answer, MATLAB will ask us not to panic and will tell that answer is 42. Suppose I am kind of a rebel and I won't answer in yes or no. If I say C, so in that case MATLAB will tell me please enter yes or no. No other characters are allowed. So how did we do this? So let's see the program. So again C will store the choice. Now here we are using MATLAB to input a string. So here again we will use that S formatting option with input so that the user won't have to enclose input in inverted commas. Then we will ask MATLAB to check whether C is equal to case Y or case N. So if it is equal to case Y, MATLAB will run this code. If it is equal to N, MATLAB will run this code. And if it is not equal either to Y nor N, we will use this otherwise block, which is an optional block, and this will run if none of the cases are matching with C. So it will print please enter yes or no. So that's how we can use the switch command. So here we have seen how to use relational operators to come to a logical decision which code to run in which condition. We have seen how to use nested if else statements. We have seen how to use the switch statement. So let's see this function Grashof criteria. It will tell us the type of mechanism given the 4 link lengths. I have already written a code for it. We will go through it line by line and try to understand it. So our first task is to check if the link lengths provided by the user are valid or not. We will check that using relational and logical operators. So this flag will store 0 if any one of these conditions fail. Since we have used AND operator, flag will be 1 if and only if all these conditions are true. Now suppose the user has provided invalid link length due to which the flag is 0. So since this condition is true, MATLAB will run this if block. So MATLAB will print a message saying that please provide valid link lengths, and then it will execute this command return. What it does is that it will exit the function and pass the control outside the function. So let's see an example for this. We will provide some invalid link lengths. Let's say first link length I provide 0, 1, 2 and 3. So if I press enter now, MATLAB will tell me provide valid link lengths, and see it has exited the function. MATLAB will not execute any of this part. It will directly exit the function with this command. Suppose the user is nice and we are provided with valid link lengths. So we will make a vector L which says links, and the vector will have elements which are the link lengths provided by the user. Now we will store the smallest link length in variable s, and the largest link length in the variable L. To extract the smallest number in the vector, we will use the function minimum, that is min of that vector, and to extract the maximum or the largest number in the vector, we will use the function max. So here let's write comments. So what we will do now is that we will separate the smallest and the largest link lengths from the other two link lengths, which we will call P and Q. So how we will do is we will delete the smallest link length and the largest link length from the vector L, so that whatever remains in vector L will be P and Q. So how we do it is following way. First we will see what is the position of the smallest link length and the largest link length. For that we will use this command isMember. So let's see in command window how this isMember works. Suppose I have a vector v which is 1, let's say 6, 4, 10 and 11. Now if I say x1 isMember 6 v, so what MATLAB will check is that MATLAB will check is 6 a member in vector v. If it is member in vector v, MATLAB will return 1. Now if I say 9, is 9 a member of vector v? No. So MATLAB will return 0. Now if I want the position of 6 in the vector v, here MATLAB is just saying 1 if it is true and 0 if it is false. Now I want to see where exactly is this element 6 in the vector v. So in that case I will ask MATLAB x1 comma x2 enclosed in square brackets equal to isMember, let's say 10 in v. So since 10 is a member in v, x1 will store value 1 and x2 will store its position which is 3. So as you can see here, x1 is 1 and x2 is 3. Now suppose I just want to work with this variable x2. I am just interested in the position of the element. I am sure that my vector contains this element. I just want to know the position of it, and I don't want to create an extra variable in my code. So for that I will tell MATLAB I don't want this position or this variable to be created. I just want the position of 11 in my vector v. MATLAB will return me 4. We have applied the same logic in our code. Here we are asking MATLAB to return the position of smallest element in L, and J2 will store the position of the largest element in L, which corresponds to the smallest link and the largest link. So now we have seen that how to delete entries in the matrix or a vector. So now we will delete these two elements. Let's again see in our vector v. Suppose I want to delete this element 11 from vector v. Now I know from this command that 11 sits at position 4 in vector v. So what I will do is v of 4, I will set it to empty square brackets. Now if I press enter, entry number 4 is deleted. Similarly here I will delete entries in the position J1 and J2 which corresponds to the smallest link length and the largest link length, so that L will contain only link lengths P and Q. So let's run our code up to this point. So what I will do, I will select these remaining and I will do Ctrl R and comment them. I will save the program. Grashof criteria, we will provide some valid link lengths this time, 2, 7, 1 and 10. So we can predict few things here, that my smallest link length will be 1, my largest link length will be 10, my J1 should have value 3 and J2 should have value 4, and final L after manipulation should contain elements 2 and 7 only. So now you can see here L is the vector created with link lengths, S is 1 which is smallest link length, L is largest link length, J1 is position of the smallest link length which is S and it is 3, J2 is position of the largest link length which is 4. We delete entries corresponding to J1 and J2 in vector L so that finally L is remaining with link lengths 2 and 7 which we have defined as P and Q. So far so good. Now what we will do is we will assign P as the first element of vector L and Q to be the second element of vector L. I am confidently writing here 1 and 2 because even if J1 and J2 are 1 and 2, after we delete those elements from L, whatever remains in L are element positions 1 and 2. Then we will define two more variables S PL, which means S plus L, which is sum of largest and smallest link length, and P plus Q is sum of remaining two. So now we come to the actual Grashof criteria, which states that if S plus L is equal to P plus Q, we will get a double crank mechanism. If it is less than P plus Q, we will get a crank rocker mechanism, and if it is greater than P plus Q, we will have a double rocker mechanism. So this completes our code, and let's run the entire code once again. So let's see what kind of mechanism we get with these numbers. So it's a double rocker mechanism. As you can see, sum of the smallest and the largest is greater than sum of the other two link lengths. Now let's see. So in this case, what we will get is again a double rocker. Let's make it 8. So here we get a crank rocker mechanism because the sum of the smallest and largest is less than sum of the remaining two. And finally we will see an example of double crank mechanism where the sum of the smallest and the largest is equal to sum of the other two link lengths. Sometimes it may happen that we are in a hurry and instead of giving 4 link lengths we may pass only 3. So in that case MATLAB will surely give us an error saying that not enough input arguments. But we don't want to disappoint our user, so we will use something called as nargin. What it does is that it will tell me how many input arguments have been provided by the user. In this case, since we have provided only 3, the nargin will be 3. In this case we have provided all the 4, so the nargin will be 4. If it is 2, the nargin will be 2, and so on. So we can actually use a switch statement in this case. So let's write switch nargin, which stands for number of arguments in. It tells us how many inputs the user has provided, and case let's say 3. If user provides 3 arguments, then we will tell user a warning. We can use this function warning. We will tell user that you have provided insufficient inputs assuming the link length equal to the first input, and then we will set our k to be equal to h. So what happens is that if I provide only 3 link lengths, MATLAB will tell me that you have provided insufficient inputs. I needed 4, you provided 3. So what I will do is I will assume the last input to be equal to the first input. Similarly, if I provide only 2 inputs, then again we will print this error message. In this case, we will assume the link lengths to be equal to the first input. So in this case, our j will be equal to h and k will be also equal to h. It may happen that user has provided only one link length. So again, we will tell user you have provided insufficient inputs, and in this case I will be equal to h, j will be equal to h, and k will also be equal to h, and let's end it here. So let's check our code with this setting. Now we will provide only 2 link lengths. So let's say Grashof 5 and 7. So MATLAB will give me a warning that insufficient inputs and assuming the link lengths equal to the first input. So my other 2 link lengths are 5 and 5. So my smallest link length is 5, largest link length is 7, and the remaining 2 link lengths are 5 and 5. So the sum of the smallest and the largest link length is greater than the sum of the remaining 2. So we get a double rocker mechanism. Similarly, you can try with some 1 input or 3 inputs. So this finishes our function here. You can also write some new function, take some concept from mechanics or something and try to write it.